Hello, hello. Let's see this. What is happening? I need more monitors, apparently. Alright, let's see. Probably will be too noisy everywhere, but let's see. Alright. Alright, let's keep working on this thing. We're gonna focus today on this part here, which is the maze puzzle. So I got some ideas. Let's see if everything will work. Basically using depth first search to generate some kind of unit-based maze in here, and every time the player will trigger that, the maze will be created. Okay, we need like a bigger section here. Let's start with that. So let me check the order of things. Let's do let's create the class first, and then let's see if we can at least compile it, because last time the Houdini engine was giving me issues. So let's call this one maze generator. Let's just throw it there, it's fine. The spline tool was working great, and I'm gonna use that one. Essentially something similar as the spline tool, but still using hierarchical instance meshes. We need some kind of formation, and the goal is to be like kind of like this maze. So let's see. Probably lots of background noise. Just hot reload everything, and we have our beautiful class. we're not gonna use Visual Studio. I just want to generate the classes, and I am using the compiler from here, but let's see. Let's use our cross-site environment here. Where's everything? That should be in the, not here. I hate Windows. Such a pain in the ass to use this horrible OS, but there's no choice for GameDEV, which is beyond terrible, but it is what it is. Into source, into the folder, and here. I'm gonna jump into our new stuff. So let's just see if we can at least compile this. Let's do some random view property, edit anywhere, and let's just give it a name. Let's just do some variable float test param equals to some float value that should be all, and in another terminal actually I do have the compiler command here. Actually I need to go where Unreal is installed, and since this is Windows, it's a horrible way of working. Anyways, we are gonna compile it with the build.bat, and we're just gonna pass the direction of our project. Let's see if we can compile it. I need to close the editor first, and let's run it. Alright, that's good. And it built. That was really fast. Alright, we take it. The very tedious part about working with Unreal Engine is that you need to close it and then build it and then open it again and so on and so forth. Yes, there's live code, but it's unreliable. Sometimes your settings won't get stored, sometimes it will fail. It's just safer if you close and open all the time, which is annoying, but it works. And it's very standard as well. Even if you're using Visual Studio, you just need to rebuild, and before that you need to close the editor. So let's see if this is working. It's complaining about, that's for the instance leaves. Oh, that's fine. So here, if we create a new blueprint, let's create a new folder. Let's call this one maze generator. In here we're gonna create a new blueprint class of maze generator, and if we drag this guy and collapse all this stuff, we should have our blueprints somewhere in here, but it's fine. Let's just see. And we have our test parameter here, so the compilation works. Usually starts like that. So let's see. All right. Go back here. And we know this works. So let's start working on the logic for this. Obviously we don't need this anymore. I usually do that if I want to check that everything is working compiler wise. What do we need? So usual stuff, we need a lot of properties. We don't need a tick function because the goal will be to have a trigger in the level. If the player overlaps, aka triggers the trigger, then a maze will be created in front of your eyes. It's gonna be super fast, but unless I want to dynamically change without the player going over and over into the trigger. Let's see, but I don't think we need a tick. So for now, let's just remove that. And let's just save it in the meantime. Just in case. We might need one if we need to implement a different part, but for now it's fine. Let's just set some data for the maze. So as a U property, edit anywhere, we're gonna have the width, the height, and we're working in kind of like units, so we will have like a, if you imagine a grid, it will be like a grid of units, so we can specify those units as well. We do want to control most things from a blueprint, so blueprint read only. I mean read this data, not actually control it. And we can give it a category here. Should we give it a subcategory? For now, let's just give the data. So this should be the width. Let's call this one maze width. Should we start unit wise? I mean, obviously this is edit anywhere, so we can change it. So yeah, same for this. That will be the height. All right. This should be, let's do this one for the cell size. Let's get 200. Should we measure the character? The idea is that we can walk in between. It will be useless if we can't move at all. So let's see anyways. Now let's copy another of these. We're gonna pass in, we need some meshes for the walls for this guy, so let's have a pointer for the mesh. Let's call this one wall mesh. And also we need the container by itself for the instance meshes. Okay, let's do it like this. I might fuck up all of this, but let's do this. So this guy will be actually visible anywhere. We don't need this. And let's see, this guy will be actually a class of U. What's the name for those things? Hierarchical instance static. Let's see the name. I would say let's look for Unreal Engine. we might have a lot, so I'm trying to figure out which one we should use here. Differences between an instant static mesh and static mesh. All right. Let's look for UEC++. The same thing. Give me the C++ documentation. Jesus. Create a hierarchical instance static mesh for procedural blocks. Kind of what we're trying to do. Okay, let's use this. That will be a pointer. Call this one. Hopefully this works the same as static meshes. I mean about the instances. We will check all of this in a sec. All right, what else we need? We obviously gonna do a function to generate the mesh. And for this one, we're gonna call this in a blueprint. Let's have another access modifier here. We will need the cells. Now, I've done a lot of these algorithms in the past, so actually we have it here, not here, but I've done it in Python. I mean, the logic is the same. I also done it in 3JS, so I know kind of like the logic, but doing it in C++ Unreal is a bit of a challenge, so that's a challenge for today. So let's see, one of these. Where do I have my mazes? Yeah, I have some maze solvers here. And the logic is very, very similar. Basically, we need like the rules for the maze, and we're gonna instance walls, and primarily since we're doing these DFS algorithms, we need to do something like this to check if we're doing a valid movement. And for that, we know we're gonna have some limits for the maze by itself. And we have directions as well. Also, we will have like orientations for the walls and stuff. Here, let's just create a struct. Let's call this one fmaze cell, and we need to check if I kind of like compare with this one. We need indeed like a structure so we can keep track if we visited the cell or not, because we don't want to be stuck in an infinite loop. Now here, let's just have a variable start as false, And also let's do for the walls. We're just gonna have 4. Let's be like very simple. At the beginning we're gonna set all of these to true. Right, so if we think about the orientation, this should be north, south, east, west. So the way I did before was with these start and end locations, and we are gonna do a recursive function very similar to this. So I'm just gonna kind of like copy this, but instead of Python I'm gonna make it C++. Okay, we do have our directions and everything, so what else do we need here? We will need some sort of container for that, so let's do a T array, and the type for this will be for the maze wall. Maze cell, I should say. Yeah. That's why we're doing the structure. And I'm trying to think. Let's call this one grid. In our case, do I have a maze? I mean, like a main function. No, that's not part of that. I think I also have one here. No, I can't even remember what this is. Experiment, maybe? Nah, that's AI stuff. Okay, I just need to think about how to do this kind of thing. Now, as we build the grid, the whole maze by itself, it will be just a bunch of instances with a unit separation instance in a certain bounds. So that's not very maze-like behavior. What I need to do is basically carve some holes there randomly. So let's call this one carve maze. We'll check that later. This is an int32. We need to pass in coordinates because it will be like two-dimensional in the sense of traversal. And also we do something similar as this to see if we have a valid movement. So let's call this one is valid. Which we also pass in x and y. Set this as constant. And what else do we need? We need to place the walls, and maybe we can do a function spawn walls or place walls. All right. Now we can start doing this. Do we need a start and an end? I'm just trying to think about that. Maybe we can start with the logic for the actually solving the maze, meaning solving by creating it, and we also need this valid and stuff like that. Alright. Let's go to the CPP. And I think do we need something else here? Last time when I did the instance stuff, let's just look for that. I think we need to import some libraries. Epic Games, why you don't have like an API documentation? I want to see about these things. And I'm pretty sure you do have it because I've seen it and used it many times, but okay, this. Include path, there we go. This is what I'm looking for. Let's go here. There we go. Now, before everything, let's just set the directions, which will be these guys, X and Y. Now, the way we're gonna do that is we're gonna set this guy in here where we're gonna have an array of 4 components, because the directions we can travel is basically up, right, down, left, in the order we can specify, which for us will be north, south, east, west. So that should be, if the first one is north, south, east, west, this is the x-axis, dx, meaning we don't want to move up or down, so that will be 0, 0, but we're going to move in these directions. And for y is the opposite, so we do want to move 1, minus 1, 1, but not left or right. Similar as I always do it here, you can see my directions here as well. And I'm just thinking about the placement. We also need some opposite walls. For that, let's do another of these. Let's have, we always have 4 walls, and this should be the opposite of north is south, so 1, the opposite of south is north, 0 of east is west, 3 and 2. Let's remind ourselves that in here, and for now let's just keep it like that. Maybe this is not gonna work though. We don't want this because, as I said before, we don't want to set this everything for every frame. It will be unnecessary calculations. So let's see. Let's have some variables in our constructor. We need this even before beginning to play, so everything that's going to be immediately built once we instance one of these guys. So let's have our instance walls. That's the name, right? Yep, for the class we have here. Now we can use the function create default sub-object, and in here we're gonna pass in the same library as we have here. That's standard stuff. We're just gonna pass this guy here. But it should be U. This is our instance vault. Alright, and we always need to add the root component every time we're using this new default sub-object, so we're gonna pass our instance vault. Cool. Begin play is begin play. I'm keeping this comment because maybe we do need to evaluate for every tick. We will just add that later if we need to. So we need to define our function to generate the maze, and we also need to carve the maze and to spawn the walls. So let's start by carving logic. Oh crap, I think I have to go actually. Should we try just an instance? No, damn it. I'll be right back.